In this video, we're going to look at the properties of sine and cosine graphs. We want to be able to find the properties of a graph or an equation that is a sine or a cosine graph or equation, and we want to be able to also describe those transformations. All right, a few other pieces of terminology that we want to be familiar with. A periodic function is just a function where the pattern repeats. So our definition here, it's periodic if and only if there's a smallest value p, such that for all x, f of x equals x plus p, f of x plus p, sorry. So really what this is saying is that I have y values that are going to repeat. So if we look at this particular graph here, we have this y value right here, which is a y value of 4. And if we go a certain amount of distance here, I'm going to get that y value again. So I'm going to get another y value of 4. And then every time now that I go this distance, I'm going to get that new y value of 4, whether I go to the right, whether I go to the left. So this horizontal distance here, that's the p-value that it's referring to in the definition. So I could do that in another place. I can say, okay, what if I look at, let's just say this y value here, so a y value of 2. So it has to be the same distance. So if I grab the same distance here, you see that I'm going to hit that same y value of 2 again on my function. If I go over here, let's go this way. So if I go over here, I'm going to hit that same y value of 2. I'm also hitting another y value of 2 in here, and that's fine. But the key is this given distance that we refer to as the period will always give me that same y value as I go through the function. So remember that y value is referred to, or that horizontal distance is referred to as the period. So my period is a horizontal distance. And then we can also talk about the frequency. The frequency is the number of cycles that occur within 1 unit. The easiest way to think about the frequency is that the frequency is just 1 over my period. Period and frequency are reciprocals of each other, so we can also say that the period is 1 over the frequency. So if we know one, either the period or the frequency, we can get the other one by just taking its reciprocal or flipping it. All right, so we want to be able to find the period of a particular periodic function. Sine and cosines are periodic functions, and those are the ones that we're usually going to be talking about. So what we want to do here is we want to find one cycle of the curve that contains a maximum and minimum, and that will also end at the same y value where it began. So the easiest way to think about this for me is to say we're going to start at the y-intercept, and we're going to trace the graph moving to the right until we hit a maximum and a minimum. It does not matter what order those happen in. And then we have to go back to the same y value that we started at. So the same y value that is the y-intercept. Then where we end is going to be your period of your function. So if we look at this first graph, I'm going to look at the y-intercept. The y-intercept is 2. So now I'm going to start tracing the graph to the right. I hit a minimum, so I've hit a minimum, and I'm going to keep going, and I hit a maximum. So I've hit the maximum and the minimum, but I have to come back to the same y value where we started. So this horizontal distance here is my period. The easiest way to figure out what that is come down to the x-axis, and that's going to be your period value. So here we're going to say the period of this function is 2 pi. So similarly on the second example, we're going to do the same thing. We're looking at a x-intercept of -4. I'm going to start tracing to the right. So I've got a minimum again and then a maximum. And then I want to go back to that same y value of -4. So I've got this horizontal line here. And where does this horizontal line end? It ends at pi. So the period of this function is pi. Okay, so we also want to be able to find the amplitude of a function. The amplitude is a little bit easier to find. It's just 1/2 of the maximum minus the minimum. So this first graph here that we're looking at, this is the graph of y equals the sine of x. So its maximum value is 1. Its minimum value is -1. So my amplitude is 1/2 of 1 minus -1, which would be 1/2 of 2, which is 1. Some people are a little bit more visual and they prefer to just kind of look at it visually and say, okay, I'm going from -1 to +1, which is 2 units, half of that is 1. So I don't care if you use the formula or if you just kind of count from the graph. You just need to be able to come up with that amplitude. So over here, this is the graph of y equals cosine of x. And again, my maximum is 1 and my minimum is -1. So my amplitude is also going to be 1 again. So the standard cosine curve and the standard sine curve, both of these have an amplitude of 1. So before we do any transformations, my amplitude is 1. And then if we look, just kind of a quick review from what we just did before, if I trace one cycle of this graph here, my period is going to be 2 pi. So starting at the origin here, trace a maximum and a minimum and then back to the y-axis. Over here, I'm going to start at 1. I'm going to trace, I'm at a maximum. I need to hit a minimum, so we did. Then we have to go back to that maximum again. And again, my period is 2 pi. So for your standard sine and cosine graph, the periods are 2 pi and the amplitude is 1. If you remember it this way, some people find it a little bit easier. The amplitude is 1 and the period is 1 circle, and a complete circle is 2 pi radians. So that is another way kind of to remember that. All right, so here we're going to find amplitude, period, and frequency of each of these graphs. So on this first one, if we start here, our maximum value is 0, and our minimum value is -6. So our amplitude is going to be 1/2 of 0 minus -6, which will give us 3. Again, if you prefer, if you're more visual and you just want to count, you can go, okay, this is 1, 2, 3, 4, 5, 6 units from min to max, and then obviously half of that's going to be 3. Next, I'm going to trace the graph. So on the y-axis, I'm at 0. So that is my maximum. So I'm going to go down and I'm going to trace to a minimum, and then I'm going to come back to that maximum. And where I end there is 4 pi. So here we're going to say our period is 4 pi, which means our frequency is the reciprocal of that, so just 1/4 pi. Okay, so over here on the second example, I'm going to move over to the right here. So here my maximum is 2, and my minimum is -2. So my amplitude is 1/2. 2 minus -2, so 1/2 of 4, which is 2. If your max and min are opposite values, then your amplitude will be the positive value. All right, we're going to do the period here. So we are at a point here that's close to 2, but not exactly 2. So we're going to kind of start there, and then I hit a maximum. I'm going to come down and I'm going to hit a minimum, and then I'm going to go back to that not quite 2 value, which is right here on this 2 pi value. So our period over here is going to be 2 pi, which means our frequency is going to be 1/2 pi. All right, 2 more examples down here. So on this one, my maximum is 3 and my minimum is -3. So my amplitude is going to be 1/2 3 minus -3, which will give us 3 again. So if I'm going to trace for my period here, we're starting at the origin, maximum, minimum, back to that 0 value, and that happens at pi. So my period is pi, so my frequency is 1/pi. Okay, and then on this last one, my maximum is 4, minimum is 0. So my amplitude is going to be 1/2 4 minus 0, or 2. Trace one cycle of the graph, so I'm here. I'm going to hit a maximum, hit a minimum, then I'm going to get back to that same value, which is looking like it's right about here. So it's halfway between pi and 2 pi. So we're going to say the period is 1.5 pi, or we're going to write that as 3/2 pi, or 3 pi over 2 maybe. And then our frequency would be 2/3 pi. When you're trying to find period like this, you're always going to end either on one of these values that is the tick mark or right in between. I would never give you one where it was like 1/3 of the way and you have to eyeball that. So it should either be on one of the graph paper lines or right in the middle. Okay, so what if we're working from the equation instead of the graph? So notice these two equations are similar, except this one has sine in it and this one has cosine in it. So they both have a in front and then b inside the parentheses, and then x minus c in the parentheses, and then we have d outside the parentheses. So this is my transformations, basically. So on either equation, doesn't matter which one I have, the absolute value of a is my amplitude. And then the b value is what we use to find the period. So we're going to go 2 pi divided by the absolute value of b is going to give me my period. It could also be 360, so it's really a whole circle over the absolute value of b, but most of the time we're going to work in radians, so we're going to use the 2 pi. The c is your horizontal shift, so notice this is minus c, and we're going to change this to c. So c is your horizontal shift. When we start talking about these sine and cosine graphs, we refer to the horizontal shift as the phase shift. So C is going to be your phase shift. And then finally you have your D, so D is going to be your vertical shift. So when we look at an equation, we should be able to come up with period, amplitude, phase shift, and vertical shift. For all of these equations, your domain is going to be all real numbers, so negative infinity to positive infinity. So both for a sine graph or a cosine graph, the domain is all real numbers. Okay, so a couple other things that we want to know here is if we're talking about the transformation, remember that we want to work in order of operations. So we would do what's in the sides of parentheses first. So the first thing we would talk about is this phase shift. So we would say we have a horizontal shift of C. Remember, we're changing the sign there. The next thing we would talk about is the B value. So remember, this is going to be my horizontal stretch or shrink. So horizontal stretch or shrink by a factor of 1 over b. So remember, we have to take the reciprocal there. So we change the sign for the c, we take the reciprocal on the b. Outside of the sine or the cosine, you have your a and your d. These are your vertical changes. So outside that, we would remember order of operations, multiply and divide before add and subtract. So now we're going to talk about a. So that's going to be my vertical stretch or shrink. So vertical stretch or shrink by a factor of a. So we don't change the vertical numbers, remember. And then lastly, we would have a vertical shift, so an up or down shift of D. So that would be my transformation in words. Okay, the other thing that we want to be able to do is come up with our range, and to have our range, we need to know our maximum and our minimum. So my maximum is always my vertical shift plus my amplitude, or in terms of the variables, that would be D plus A. Our minimum is vertical shift minus the amplitude, or in terms of the letters, D minus A. So then that means that my range is going to be whatever my minimum is to whatever my maximum is, and those will always be in square brackets. All right, so if we look at an example here, remember that back here, it said this must be in factored form, so when we look at the x value, it needs to be in the parenthesis, the smallest parenthesis. It needs to not have a coefficient in front of it. So if we look at this one, in the smallest parenthesis, x does not have a coefficient in front of it, so this is in factored form. So we don't have to do anything with this, so we can just start finding our properties now. So my amplitude, remember, is this number here, and it's just the absolute value of that, so nothing we have to change there, so 3. This is the number that I'm going to use to find my period, and remember, it's always 2 pi or 360, but we're going to work predominantly with radians, divided by that b number, which is the pi, so those would cancel out and leave me with 2. Next, I want to find my phase shift, and that's from this number here, and all we do here is change the sign, so this is going to be pi over 4. And the vertical shift is what's added or subtracted outside the parentheses, so my vertical shift is just 1. So once I have that, then I should be able to find my maximum or minimum. So remember, this is vertical shift plus amplitude. So in this case, we're going to do 1 plus 3, which will give me 4. And over here, this is vertical shift minus amplitude. So this is 1 minus 3, which is going to give me negative 2. So remember, my domain's always all real numbers, so negative infinity to positive infinity. And then my range is minimum to maximum in square brackets. And then we want to talk about the transformation, remember? So we want to do order of operations, so what's inside the parentheses first. So that's going to be my horizontal. So we've got a horizontal shift pi over 4 to the right. Because remember, we're changing the sign on that. So it was negative pi over 4, but we're going to change it to positive pi over 4, so we're moving to the right. And then here we have pi, so remember, we'll take the reciprocal of that, so 1 over pi. So we have a horizontal 1 over pi is less than 1, so that's going to be a shrink by factor 1 over pi. Next, we've got the 3, so that's my vertical stretch by factor 3. And then finally, we're going to shift up 1 unit. All right, this last example here, remember, first thing we're going to do is look at x here. X has a coefficient on it. It's 1 over 2. So we need to factor out that value. So remember, it has to be in factored form before we can start finding our properties. So this is going to be y equals 2 cosine. We're going to factor out the 1/2, which is going to leave me with x. So remember, when I'm factoring out, I'm dividing by 1/2. Or instead of dividing by 1/2, we can think of this as multiply by 2 over 1. So then this is going to end up giving me here minus pi over 2, and then plus 1. So then again, once I'm in this factored form, now I can start looking for my properties. So remember, this value here is my amplitude. This value here I'm going to use to find my period. So this is going to be 2 pi divided by 1/2. So remember, that's 2 pi times 2, which is 4 pi. Next, we have this value here, which is my phase shift. Change the sign on it, so pi over 2. And then finally, we have our vertical shift of 1. So once I have that, now I can find my max and my min. So remember, maximum is vertical shift plus amplitude, so I'm going to get 3. And then minimum is vertical shift minus amplitude, which is negative 1. My domain is always all real numbers for sine and for cosine. And then my range is going to be minimum to maximum. And then if we discuss the transformations, remember, order of operations. So we've got a shift pi over 2 units to the right. My b value is 1/2. Remember, we're going to take its reciprocal 2. So this is going to be a horizontal stretch by factor 2. Outside, I have another 2, so that's also a vertical stretch by factor 2. And then finally, we have a shift of 1 unit up. So looking at that equation, you should be able to find all of the properties, and you should be able to describe the transformation.